G'day guys, last time we talked about true north, grid north and magnetic north, and that's fine when you're using field compasses, but when you're on a ship or in an aircraft you need to factor in something else, and that's called magnetic deviation. So magnetic deviation is the error in the compass that's caused by the metal in the aircraft or in the ship that you're operating in. So that error is fixed in the ship, and it doesn't matter whether you're in Australia or in the United States or where you are. If you're in that ship or that plane, then the magnetic deviation will be the same. The way we determine magnetic deviation is with a technique called swinging the compass. Swinging the compass means we point the vessel or the aircraft in various directions, and we compare the magnetic heading of that craft with the compass reading that you're getting. So you can do that in ways like you can use transits. You can line up the vessel between 2 points, and if you're heading directly towards one of those 2 points and you're between the two, then you're on a known transit, so that can give you a definite heading. Known magnetic headings. Other things like you can use a handheld compass, though you have to bear in mind any errors that might be in that handheld compass. You can use GPS, but you do need to be aware that with GPSs that you have to be travelling for many of the GPSs to actually show a heading, and you have to be aware that if you're in a plane, that if there's crosswinds, or if you're in a ship, if there's currents, that will actually affect the direction that you get on your GPS. So you can't always rely on a GPS to provide that exact heading that you need to swing the compass. There's another technique which I actually quite like, which is that you can get a sundial, make up a sundial with a disc and a spike, and if you know the time and your location, you can actually get information about the heading of the sun, and so you can determine the heading on your compass based on the heading of the sun, which is a really neat and quite cheap way of getting that information. Once you've done all this changing of headings and recording the difference between the magnetic heading and what it's appearing on the compass, you can create what's called a deviation card. Now there are specialist people who go out and do this on commercial vessels and on commercial aircraft. They will go out and swing the compass, and they will produce either something like this called a deviation card, or they'll produce the equivalent thing in a graph that will show you the distance east or west from the particular heading. So you can see on this deviation card that if you want to steer a magnetic heading of 000, the heading you would steer on your compass is 357. Similarly, if you want to steer magnetic 225, you'd steer a heading of 228 on your compass for this example deviation card. So when converting from true to magnetic, we always consider variation, and we were talking about that in the previous video. When we're converting from magnetic to compass, compass to magnetic, we're considering deviation. And so that when we go from a compass heading and ultimately draw it on our map with a true heading, we need to convert compass to magnetic using the deviation, and then we need to convert the magnetic to true using the variation. If we're considering easterly variation and easterly deviation, we need to add those to our compass or to our magnetic heading if we're going from compass through to true. That's shown by this arrow here. And if it's westerly, then you need to subtract those deviations and variations. Similarly, if you're going from true down through to compass and you're in a westerly variation, you need to add your westerly variation, or if it's easterly variation, you need to subtract that easterly variation. The same with deviation. If you're going from magnet to compass and it's westerly deviation, you add it. If it's easterly deviation, you subtract it. So let's look at an example. If you have a heading of 225 degrees on your chart, 225 degrees true, and you want to get the compass heading that you can follow in your ship, you need to subtract your easterly variation. If we're 11 degrees east, we would subtract that, and that would give us our magnetic heading of 214 degrees magnetic. If on this ship the deviation at 214 degrees magnetic is 3 degrees west, then we would add that to our magnetic heading, and that would give us 217 degrees compass. If we look at this bottom one and we wanted to get the true heading on our chart from a compass heading of 161 degrees compass, with an easterly deviation, we need to add that easterly deviation, gives us 163 magnetic, and then we need to subtract our westerly variation, 6 degrees west, and that gives us a true heading for our chart of 157 degrees true. So I hope that makes sense in terms of going from compass to magnetic heading and vice versa using compass deviation. There's plenty of examples on YouTube and on the net on how to swing your compass, and more examples of how to put compass deviation into your navigation calculation. So I encourage you to do that. If you like this video, please give us a thumbs up down below. I'd really appreciate that. And of course, if you're interested in any more videos in terms of navigation, then subscribe and we'll do some more. And of course, if you want to leave comments, please feel free to do so down below. Thanks for that. Bye-bye.